Chapter 5, Section 1, Using Integers as Exponents. So in this chapter, we're going to deal with exponents and radicals. So this slide is just a review of all of the exponent laws that we learned in Chapter 3. So you can just review those on your own if you need to. The only new one that we're going to talk about, and we did talk about it in 098, is the inverse rule. So anything to the negative power means you need to get rid of that negative exponent, which means you're just going to take the reciprocal. So for this one, and like I said, we are going to work with it a lot in this section, but if you have b to the negative n, that's understood to be over 1. And if you take the reciprocal of that, which would be 1 over b, that's going to give you the positive n. So that's how you're going to get rid of those negative exponents. If it's on the top, you're going to push it to the bottom. If it's on the bottom, you're going to push it to the top. Okay, so let's review working with these negative exponents. Again, if you have 4 to the negative third power, again, that's a whole number over 1. So we take the reciprocal of it, and we're going to get 1 over 4 to the third power. And then the numbers that are not too gigantuan, I would like you to simplify, but if there's a number that's going to be a huge number, you don't have to simplify. It's personal preference, I guess. If you can do it easily, do it. If not, that's fine. Now, this one, if you have a fraction and the negative exponent is on the outside, what I'd like you to do is take the reciprocal of the fraction and then raise the exponent as positive. So you're going to take the reciprocal of the fraction inside, and then your exponent's going to go from negative to positive. From here, this is your exponent rules that we learned in Chapter 3. So the 3 gets squared and the 2 gets squared. So you're going to square the top and square the bottom. And again, down here, don't forget about your power rules that we learned in Chapter 3. So here we're going to do the inside first. So when you multiply powers with like bases, you add those exponents. So on the inside, we're going to get 3 to the negative 1 raised to the negative 1. And then again, in Chapter 3, we learned that a power to a power, you multiply those exponents. So you're going to get 3 to the positive 1, which is simply just 3. Okay, the next one, again, when you divide powers with like bases, you subtract those exponents. So this is going to turn into a 2 to the 3 minus negative 2. Again, when you divide powers with like bases, you subtract the exponents. It's always going to be top minus bottom. So that's going to be 2 to the, because a double negative goes to plus, so 2 to the 5th power. And again, you can put that in your calculator and come up with 32. Alright, the one in the middle, again, if you multiply powers with like bases, you add exponents. So we're going to get 4 to the 0 power raised to the negative 1. And then power to a power, you multiply those exponents, and anything to the 0 power is 1. So the one on the bottom, again, I want to take care of this negative exponent. So to take care of the negative exponent, what I'm going to do is I'm going to take the reciprocal of inside. But when I take the reciprocal in the side, watch what happens. You get 3 over 2 over 3 negative 1 over negative 1. So, I'm sorry, over positive 1. So if you notice, the only thing that changed is this negative exponent on the outside. None of the exponents on the inside changed. You just take the reciprocal of the fraction as is. So you're going to have 3 over 2 on top and 3 to the negative 1 on bottom. And then this negative 1 is going to go to positive 1. So now, in order to do what's inside, of course, anything raised to the first power is itself, so we're not even going to worry about that 1 on the outside. But when you divide powers, you subtract those exponents. So again, you're going to have 3 to the 2 minus negative 1, top minus bottom. So you're going to have 3 to the 3rd power, which is 27. Okay, so now let's deal with some variables. Again, when you multiply powers with like bases, you add those exponents. So this is going to turn into x to the negative 3. And when you write your answer, you do not want negative exponents. So that's going to be 1 over x to the positive 3. Again, when you take your test, just understand that if any answer is left with a negative exponent, I will mark it wrong. We want positive exponents only. So the one in the middle, we have a power to a power. So you're going to multiply exponents. So this is going to be x to the negative 8. And again, we don't want negative exponents in our answer, so we'll take the reciprocal and get a positive 8. Okay, the last one, remember how we fixed this on the previous slide. So we're going to take the reciprocal of the fraction. Don't change anything, none of the exponents or anything like that. And then the outside, negative 1 comes to a positive 1, but again, anything to the first power is itself. So now, in order to take care of the negative exponents on the inside, we're just going to use our rules that we learned from chapter 3. So to divide powers, you subtract the exponent, so we're going to have negative 2 minus a negative 4. So that's going to be x to the positive 2, or x squared. Alright, for this one, remember, if you don't have addition and subtraction on the inside of your parentheses, if you're just dealing with monomials, and that's key, if you're just dealing with monomials, you can take this external exponent and distribute it here. And I'll break it up for you. So this is going to be x to the negative 3 raised to the negative 2 times y to the 4th raised to the negative 2. So you can see that each factor inside the parentheses gets that negative 2, gets raised to the negative 2. So then you're going to use your power rule. X to the negative 3 raised to the negative 2 is going to be x to the 6, power to a power you multiply. And then for this one, you're going to get y to the negative 8. Well, we don't want negative exponents. So what you need to understand that if you have a negative exponent, you're looking at a fraction. So if you have a positive exponent, it's going to stay where it is. But if it has a negative exponent, you're going to take the reciprocal. So y to the negative 8 is on top right now. So to get y to the positive 8, you're going to push it to the bottom. Again, if you have a negative exponent on top, push it to the bottom. If you have a negative exponent on bottom, push it to the top. Okay, so same thing with division, which actually this is multiplication and division all in the same problem. Every factor inside those parentheses gets raised to that negative 3. But it may be easier to go ahead and take the reciprocal and take that negative 3 to a positive 3. I think that would make it easier. So again, every factor gets raised to the 3rd power. So we're going to have 3 to the 3rd power. We're going to have b to the 4th to the 3rd power. And we're going to have 2 to the 3rd power. And a to the negative 1 to the 3rd power. So 3 to the 3rd power is going to be 9. b to the 4th to the 3rd power is going to be b to the 12. And 2 to the 3rd power is 8. I'm sorry, 3 to the 3rd power is 27. So that top is going to be 27. And then b to the 12th. And then on the bottom, you're going to have 2 to the 3rd power, which is 8. And a to the negative 1 to the 3 is going to be a to the negative 3. And again, we need to fix that. So you're going to have 27, a to the positive 3, b to the 12th, over 8. Again, if you have a negative exponent in your answer, if it's negative and it's on the bottom, you're going to push it to the top. But if it's on the top, you're going to push it to the bottom. You've got to get rid of those negative exponents. Okay, so this one, again, we're just dealing with monomials. So when you multiply monomials, you're going to multiply your coefficients. 3 times 4 is going to be 12. And then you multiply like bases by adding exponents. So x to the 2nd times x to the negative 3, we're going to add those exponents. It's going to be x to the negative 1. And then y to the negative 4 times y to the 1st, again, we're going to add those exponents. So we're going to get y to the negative 3. Now, I need to get those negative exponents out of my answer. And I need you to understand that 12 has its own exponent of 1. So when you write this, again, if you see a negative exponent, you're looking at a fraction, so go ahead and make it into a fraction. The 12 has an exponent of positive 1, so it stays as is. But the x needs to go to the bottom as a positive 1, and you can write that or not. And then the y needs to go to the bottom as a positive 3. So when you divide powers, again, you're going to get that out of your way. When you divide powers, you're going to subtract. So initially we're going to do 12 divided by negative 3, which is going to be a negative 4. And then for our variables, a to the third minus a to the negative 1. So again, you have a to the 3 minus negative 1, which is going to be a to the positive 4, so that's going to go on top. But for b, set b to the second over b to the fifth, you're going to get b to the negative 3, so that b to the positive 3 is going to go on bottom. Another way to look at that is you have b times b on top, and then on bottom you have 5 b's. And these two will cancel out 2 of these, leaving with 3 more on the bottom. So your answer is here. Okay, so the last thing we're going to talk about is how to express as a single fraction involving only positive exponents. So why is it that we're talking about that this is even a fraction? Because it doesn't look like a fraction. Well, remember I told you if you have negative exponents, you are looking at a fraction. So you can go ahead and make fractions out of these. Now, we have the sum of 2 different terms. So these are 2 separate terms. So we're adding fractions. So it's going to be 1 over x to the positive 2 plus 1 over y to the positive 1. And remember, to add fractions, you have to have a common denominator. So that common denominator, and we learned this in chapter 4, your common denominator is going to be x squared y. So to get a new numerator here, I need a y on top and bottom. So you're going to get y here. Here, I need an x squared on top and bottom. And again, we covered that in chapter 4. So now to make a single fraction, one fraction, so we're going to have y plus x squared over x squared y. And if you want to write it in descending order, x squared plus y, that's fine. But this will not reduce. This is a group, so you can't cancel anything out. So that's going to be your answer. So let's try that again. Again, we have 2 different terms, and I see negative exponents, which means I have 2 different fractions. So to rewrite this, we're going to have 1 over a squared minus 2 over ab. Again, the 2 has an exponent of 1, so leave it alone. So the common denominator is going to be a squared b. So to make this fraction look like this fraction, I need to multiply the top and the bottom by b. So I'm going to have b over a squared b. And to make this fraction, the denominator, look like this denominator, I need to multiply by an a on top and bottom. Alright, so now I'm ready to make a one fraction. So we're going to have b minus 2a, and again, if you want to put it in descending order, that's fine. So we have b minus 2a over a squared b. So again, a lot of this is combining the knowledge that we learned in chapter 3 as far as our exponents are concerned, and then this portion, how to add rational expressions, which we did in chapter 4. So what I'd like for you to do is I'd like for you to complete these numbers. I know it's a lot, but this stuff needs a lot of practice, and once you get used to doing these, it won't take very long at all. So you should go through these pretty quickly. If you have any questions, just bring them in